he wrote, Winston Churchill once said of Russia that it was a riddle wrapped in mystery inside an enigma. Were the British bulldog a physicist, he might have been talking about an electron. So you see, a riddle wrapped in mystery inside an enigma. And of course, we will solve that riddle today. But the interesting question, of course, for us is it possible, is there a possibility of a sort of Goetheanistic approach, as we mainly try here in the science section when we work on a scientific project? Is it possible? Definitely not like we, let's say, are used to by comparing leaves, comparing plants, comparing bones. That is definitely not possible here, because there's nothing to perceive about the electron, at least not in a direct way. And so my approach in this lecture will be that at first I would like to explain a little bit, and I hope it's not too technical and not too superficial, the two dangers, Scylla and Charybdis, and to a little bit to explain how people came to this concept and how people came to the problems connected with this concept, at least some of these problems. And then in the second part, I will try to tell you a little bit how I tried to approach it in a, let's say, semi-Goetheanistic or anthroposophical way. That will be the second part. So everybody who thinks of an electron normally thinks of a very small particle, very light, with negative electric charge. And the discovery of this particle is normally connected with J.J. Thomson, an English physicist, but there were others before him who did similar observations, but didn't go that far as Thomson went. And actually, the name electron came from the person who is sometimes called the Chancellor. In German, we have this word Reichskanzler, and at that time it was Bismarck, and he was called the Reichskanzler of Physics, Hermann von Helmholtz. He was a very interesting physicist, and he, together with another person, coined the name electron when they thought about something like an atom of electricity. And what Thomson did was he used what I would like to call, following a little bit Ernst Lehr's, what I like to call radiating electricity. He had a tube which was evacuated, and two electrodes inside the tube, one negative, another one positive, and then he put a huge tension between the two, electrical tension between the two electrodes, and then one can observe, if there is this little amount of gas in the tube, one can observe a sort of radiation. And he made experiments with this radiation, and I found a picture of the tube he used, and I would like to show that to you. This was Thomson's tube. It's called a cathode ray tube. And as you see, it's from 1897. And on the right side there is the cathode. And with these slits, he formed a beam of the radiation coming out of the cathode. And then here are two magnets. And with that, he was able to deflect the beam. And by that, he was able to calculate the ratio of charge and mass of something, what he thought is flying there. And he discovered that it is independent from the material of the cathode here, and independent of the material of the gas which might be left in the tube. So it's something independent of the matter, and therefore he is mostly named as the person who discovered that. And this is a modern form of this experiment where you see where you see, because of the gas inside this round tube, you can see the beam in this magenta color. And it is a circle here because these big coils form a magnetic field, and that bends the beam to this circle. And there's more a schematic view of that, the beam without magnetic field, and then with a magnetic field. And that is, so to speak, a schematic view of the modern aspect of this experiment. A little bit later, they tried to find out whether that is really a sort of atom for electricity. And the person who succeeded to do that was Robert Millikan in the United States. And he did the following experiment. I will show you again. He sprayed oil in a chamber, and here he has two plates, and some of the oil drops come through this slit between the plates. And the plates are connected with an electric field, so electric tension. One is grounded and the other has several thousand volts. And so the oil drop is in between that. And if the oil drop is a little bit charged, it should move in this field. And with this microscope, one can observe the oil drop, how it is moving. And by this movement, one could very fine measure the charge. And so Millikan measured hundreds of oil drops between that. And what he found was very important because some oil drops had a certain charge. Others had twice the charge. Others 3 times the charge, but it's always the same base of, as some of you might know, 1.6 times 10 powered by minus 19 Coulomb. And that seems that electric charge can only be there in multiples of that, so to speak, ground charge. Here you can see the apparatus Millikan originally used. There he sprayed the oil to make the oil drops, and there is his microscope to look into the apparatus. And the next picture, that's a modern version of it. So you can buy that for school or university experiments. And this picture shows another aspect, and you will soon see why I show it. People discovered after some years, it took some time, but to see that radioactive beta radiation is behaving in the same way as this electron rays. And when you put this such an radioactive element in a chamber, which is called a cloud chamber, where, for example, is vapor of alcohol, but it is in a state where the vapor is about to condensate. And then it will condensate at first along traces like this. Lots of droplets of alcohol along this path. And of course, that gives the impression there is a particle flying along that path. And that is a different particle. And so people came to the conclusion that it is this radiation consists of particles because of a picture like this, and that is particles which are charged with this basic charge of an electron. I might add here for purists that today we know that this picture, a picture like this, is not a 100% sure indication of particles, because there are other ways to explain that, but I will not go into that. Then that was, Millikan was around, was in 1909. And then the next step, of course, we should mention was Niels Bohr. And Niels Bohr pictured, out of some experiments by Rutherford, pictured the atom like a planetary system. And similar to how we do it today, with a small nucleus where all the mass is concentrated and the electrons flying around it like the planets around the sun. The problem is only certain orbits are allowed in Bohr's model, and there was no reason, he could not explain why, but this model was very successful in calculating the spectrum of hydrogen. But it had this problem, we don't know why only these orbits are allowed. Nevertheless, so 5 years later, people knew already that Bohr's approach could not be true. Nevertheless, it states the right questions. Bohr was an artist with questions and conversations, and for a physicist, there are some physicists who have wonderful biographies and personalities, and Niels Bohr was certainly one of them. And in his institute, there was always conversation and conversation and conversation, so that one of his colleagues later said, our publications shouldn't be marked with an author, because we are all authors of everything. We should just say from the Institute for Theoretical Physics in Copenhagen. So because of this wonderful mood of conversation around Bohr. But so he put the right questions, but people didn't know how to approach them until in 1924, a French physicist, actually a student, looked closer at the work of Albert Einstein, and he knew about the problem with light and wave and particles, that light sometimes behave like waves and sometimes like particles. And he got the idea and formed that out, that every particle can have wave properties. Isn't that strange? So macroscopic particle like sand is not included yet. But for the small particles, he thought it must be possible. And that actually he wrote in his dissertation. And the committee who had to approve his dissertation was not sure about it. And they sent the dissertation to Albert Einstein. He read it and was fascinated and wrote back, wonderful, very interesting idea. And I think 8 years later, Louis de Broglie was his name, got the Nobel Prize for this idea. And the question is, one important result is that with his waves, de Broglie was able to show a reason for Bohr's orbits. Because in that case, the wave of the electron should fit into the orbit. I will show you a picture of that, because it's like this. You see, in that case, there are just 6 waves which fit into the orbit. And if the orbit would be a little bit larger and the wavelength would be the same, it wouldn't fit. And so de Broglie was able to say, in Bohr's orbits are only permitted if the wave fits into it. And it's like a standing wave, or now it comes, like the wave of a string. When we have a string and produce a sound with a string, like on the piano or the violin or whatever, we have waves like that. I say that because Steiner connected the chemical ether with the sound ether, and it's interesting that there are so many, let's say, light connections of that. It's not the same, but it's like is a light touch. Now the question was, what is the wave made from? You know, when we have water waves, we know it's water in this wave motion. Or when we have sound, it's the air and the pressure of the air. And when we speak of radio waves and even sometimes light, we think of electromagnetic waves. But here, the question was open. One didn't know. And the first step was, is it possible to find an equation which describes that wave? And that was achieved by the Austrian physicist Erwin Schrödinger. And everybody who has a little bit knowledge about physics knows the Schrödinger equation, at least by name, because it's the fundamental equation for quantum physics. And it was shown shortly after it was published that it was equivalent to the approach of Werner Heisenberg 1 year earlier. So that was, so to speak, the birth of quantum physics. This equation Schrödinger found to describe the electron. The problem is many strange things. We still don't know what is the wave made of. We only know from the equation to describe the wave. And it's always called with the Greek letter psi. And when you look at this equation and do some mathematics with it, it is really surprising that it is necessary to include complex numbers. So we all know numbers like 1, 2, 3, 4, 5, and we all know numbers like 1.5 and 1.75 and whatever, fractions and so on. And we know negative numbers like -1, -2, -3. But if we square, like 2 squared is 4, if we do that, we always get positive numbers. So -2 times -2 is +4, because minus times minus is plus. And complex numbers have the property that they include the square root of a negative number, like square root of -1. And there our imagination of numbers comes to a certain barrier, but in mathematics we can handle them quite well. But in connection to physics, up to that time, they were only used for mathematical practical purpose. But in the end, we always use the ordinary part of it, the real part, as it's called. But now it was necessary to deal with the imaginer, so the complex part as well. So it is something out of the ordinary physical world. That was one thing. The other thing was nobody had observed waves of matter. So the next question was, is it possible to observe something like wave behavior? And the first who did that were people here in the United States, Davison and Germer. They, in 1927, had a beam of this radiation, electron radiation, on a crystal. And they found the crystal reflected it in the same way or similar way like it reflects X-rays. And one could understand out of that there must be waves. A little bit later, I think it was in the 60s, people tried to do the famous double slit experiment with electrons. And I would like to explain that a little bit. So, here is an image of waves coming from two small slits. And the waves are, after the slits, are circles. A group of circles around this slit and another group of circles around that slit. And so we have two systems of waves coming together, and at certain part of the field, at certain parts, the waves interact in a way that the spike of the wave interact with another spike, and it's higher, and the trough is lower. And then we have these regions, like here and there and so on, where we have, from the interference of the two wave systems, an attenuation. The wave is stronger there, and in between, nothing. And then they did that, with light. That's an image of a candle through a double slit. And you see, then we have multiple images of the candle, even starting here, which are colored with the candle. And from these colors are the reason that people say, for example, here red has a longer wavelength than violet. But we have this pattern, this and this and this and that, what is called the interference pattern. Interference is this interacting of waves. Now, let's look at the next picture. That is the experiment. For that, a little bit more complicated, not a candle anymore, but a laser. Here's the double slit. And there on the screen, you see the interference pattern. And because the laser doesn't allow any other color than its own, we have only this color here. So that is the build-up of the experiment with light. And that is a possible image we can get. Here it is done with a laser, always green, and here with ordinary light with colors. And this is how we can find this in nature. You see, there are small droplets in the cloud, and then we can see, and you all have seen that around the moon probably, we can see a periodic pattern from here to there, with the red as before on the outer side, and the sun here behind the tree. It's wonderful and beautiful. And now people try to do the same with an electron. Here they produce the electron beam. And this is a sort of very thin plate of graphite. And this acts like the like the droplets in the cloud, only much, much smaller. And what we get on the screen are again these periodic rings. There is an actual picture of that, not schematic, unfortunately in German, but it's only screen and diffraction rings, circles of electrons. So a very strong indication of wave behavior. So similar to this. And then much later, this guy, Tonomura, made a very interesting and striking experiment. He made the beam lower and lower and lower until he could be sure that all the time there is only one electron in the whole experiment with a double slit. So we would expect the electron to choose one of the slits, tunnel to it, and then form a dot on the screen. And he did this experiment for about, I think it was originally about 20 minutes. And in the beginning, these dots seem to be randomly distributed. And if there are videos of that, of course, but I didn't want to show a video here. So when you look at the screen, and I've seen that myself, then they pop up, dup, 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 dup. So then he waited a few minutes. It was like this. And there you see already what's here, what's there, what's there. And a little bit later like this, and in the end like this. And then you have an interference pattern. But there was only one electron in the apparatus. How is it possible? Can it make interference with itself? So from there come many disturbing thoughts about quantum physics, so much that, for example, Richard Feynman used this experiment to introduce quantum physics to his students. And for example, when one adds the possibility to know which of the two slits the electron is choosing, because if it's a particle, it should go through one slit or the other. And if one adds the experimental possibility to know about that, it's not even necessary to really know. Only the possibility to know about it, and the pattern, this pattern will disappear. So it's really strange, a strange behavior. And so there are some really strange properties to what we like to picture as a simple small particle. And I will add a few. For example, people tried to experimentally find the size of this particle. You know, for example, they did it that way, that they shoot two particles together. And of course, there is some electric repulsion, because minus and minus are going to separate. But if the beam is stronger, they come nearer and nearer and nearer. And people try to find out at what length there is anything else than this electric force, because they thought at some point they should hit in each other. But until today, one never found that closeness. It is done, for the physicists, I say that, it's done down to 10 powered by minus 19 meters. So that means 1 over 1 with 19 zeros part of a meter. So that in modern textbook, when people ask the question, what is the size of the electron? The size is 0. Now, can you imagine a particle with a size 0? It's, so to speak, not really present in space. And then this problem with a wave, then people looked at electrons at an ensemble of electrons. And then they did statistics with that. And what one found, it is necessary to realize that it is impossible to distinguish one electron from the other. So it's impossible to say, now I will follow these electrons moving around in space. Impossible. They are indistinguishable. I found an interesting article by a theoretical chemist who compared the concept of an electron by the chemists, the small particle responsible for bonding and all that, and by the physicist, which is totally different. And of course, being a physicist, the physicist approach is much closer to reality than the one of the chemists. They only do it because it works. So that's another problem. And so that gave rise to the question, is it possible to follow, to interpret the path in the cloud chamber as a path of a particle? And still until today, it's debated what is the meaning of this wave function. It is not clear. We don't have a concept what this wave function really is. And so we see that this enigmatic electron is definitely not something like a particle of sand, dust, or so, but something quite different. And now, how can we approach such a problem? And I will tell you two ways I tried that. The first was, I thought, if it is not perceivable, it is some sort of a concept of an idea, but how, when Steiner described thinking, for example, in the philosophy of spiritual activity, he once described it is like, thinking is like seeing. Seeing perceives light and thinking perceives ideas. And that doesn't mean they are subjective, but they can have a real meaning, a real existence in the world. And so I thought, what is the use of this idea of the electron? And to find that out, I considered, how do we use the concept of an electron in science? And when we do that, we find, of course, first, for example, charge transfer. If we think of an electrical current, people think of moving electrons. It is not quite the right concept there, but part of it is. So charge transfer. Then another thing is where it is very intensively used to describe, to understand chemical bonding. So, for example, when you have sodium chloride, the chlorine gives one electron to the sodium, which can fulfill one of its shells, and so the chlorine is left with positive charge because negative is missing, and the sodium with negative charge because of an additional electron. And that explains what we use as salt on the table, this bonding. And it explains how it is diluted in water and so on. And there are many, many other examples. Always chemists use the electron configuration to explain the bonding. And then there's another thing. When a gas emits light, like for example in old neon tubes, when a gas emits light, we explain that with transitions of the electrons in the atom. Therefore, Niels Bohr could explain the hydrogen spectrum with his electron orbits. So it is, when you look at these examples, you see the electron transfers charge. It's something in between. The electron is responsible for chemical bonding, something in between. One atom or matter and the other atom. When you look at the light, the electron is, we make the electron responsible for the interaction of matter with light. Again, it is in between. The electron seems to be always mediating between something, like light and matter, different sorts of matter, and so on. That was my first approach, that we have to do with some quality of mediating. We connect with this idea of the electron. And then I remembered a very interesting and challenging suggestion by Rudolf Steiner. And that is from 1924, January 1924. And there are lectures about medieval Rosicrucian initiation. And there he describes how the Rosicrucians took up the task to impregnate themselves with the concepts of the developing materialistic science. With all these concepts and pictures. And so I might add, it's like they picked up what is forming this occult prison. And they took that up and carried that in their meditation to the spiritual world, and then were able to receive an answer what the reality or the truth connected with these concepts might be. And that seems at first like an historical description by Steiner, but then he goes on, and I know it's very difficult to read texts on PowerPoint, but this quote I wanted to show you, and if you are tired of reading, just look at the date of the lecture. That should be here, yes. Steiner goes on, this possibility has remained until this present. It is so indeed, my dear friends. If you are touched by the Rosicrucian principle as here intended, study, that's a challenge, study the system of Haeckel with all its materialism. Study it, and at the same time permeate yourselves with the methods of cognition indicated in knowledge of the higher world and its attainment. Take what you learn in Haeckel's anthropogenesis. In that form, it may very likely repel you. Learn it nevertheless. Learn all that can be learned about it by our natural science, and carry it towards the gods. You will get what is related about evolution in my outline of occult science. So here you see the date, 13th of January in 1924. So on one hand, Steiner here lets us look into his workshop, because he describes how it is possible to come to these 4 great steps of evolution in occult science, from Saturn, Sun, Moon to Earth. On the other hand, he challenges us to do the same. And I don't know whether anybody of our anthroposophical friends has ever tried that or achieved that. And of course, I will not claim that I could do that, but I always thought, is it possible with the ideas of modern physics as well? So I tried to do that. It is unfortunate that Steiner did not explain what he means by the methods out of this book about knowledge of the higher worlds. So it's a book, there are lots of exercises there, and he did not explain which one is possible to do that. And I tried just to take these images we have about electrons and electron orbits and so on today, and try to take them up in my meditation. And the interesting thing is, probably it is not so that now I have an insight and can tell you what the spiritual meaning of the electron actually is. But it helps when you go with that into your meditation and then go to sleep, that you carry that into your sleep. And then you are more able to be aware of ideas the next day or days. And out of that, and I don't know whether it is related to this exercise or not, but I got a certain idea. I looked at the whole what we today call the standard model of elementary particle physics. And I realized in this whole model, we have just 3 stable particles. Most of the particles we know, and you know, people speak about a zoo of particles there, most of them have a very short, it's called lifetime, whatever they think with that, very short span of existence, and then they decay or disappear or something. And there are only 3 really stable particles, and let us look at that. Here we are still with the Steiner quote. And these are the electron, the photon, which is connected with light, the particle of this radiation, and the proton. And the proton is, for example, the nucleus, what people picture as the nucleus of the hydrogen atom, and many protons are the nucleus of different elements, other atoms. Now let's look at this standard model. There are different ways how to visualize that, and this is the most common. And there you have, when we leave out the Higgs boson, we have 3 groups: the violet ones, the orange ones, and the green ones. The violet ones are here called the quarks. Quarks are not observable, only indirect. And what I called as a proton is made up in the theory of 2 or 3 quarks. And therefore I put the blue circle around that. Okay, come there, this. That is, so to speak, connected with the proton. From the greens, called leptons because they are very light, we have the electron, and all the others are decaying very fast. And from the oranges, here they are called bosons, vector bosons. I will not go into that. Only the photon is stable. So we have again the 3. Now we go on. We have the 3 particles representing these bosons, which are connected with interaction, radiation, the electron, and the proton. And when we look what they are connected with, the photon is connected with light, radiation, energy, just going up into the space. The proton is connected with, too fast, with matter, mass of matter, mass of the nucleus. For example, hydrogen, the nucleus of hydrogen, and 2 protons are the nucleus of helium, and so on. So it's connected with the chemical properties of an element and, so to speak, matter and mass. The opposite of light and energy, and the electron, as I tried to describe, mediating in between. And that I connected because it's something I feel close every now and then, with a symbol which Steiner described in these same lectures on the Rosicrucian initiation, the symbol where on one hand, this triangle is connected with light and the other one is connected with gravity. So we have this symbol here as it is drawn at the blackboard by Steiner with these words, light streams upwards for the upper part of the drawing and weight bears downwards for the lower part. Some of you might know this two sentences from eurythmy because I think even after Steiner's death, eurythmists found that and thought it's a wonderful eurythmic exercise, even in therapeutic eurythmy. So most people today know it from eurythmy, but it comes up in these lectures as a symbol of meditation for the Rosicrucians. And I connected it with these three: the photon connected with light, the proton connected with weight, and the electron mediating in between. So one can ask, what does that mean? And the fact is that one can find or discover a sort of threefoldness in the realm of elementary particles. And that alone is something where I was quite enthusiastic about, that it is possible, even on that level, the level of the standard model of modern particle physics. And of course, I know that it is questioned and there are maybe further developments and so on, but it holds quite well for lots of tests. And even there, it is possible to discover a threefoldness. And then there's a lecture where Steiner once said, I can't give you the quote right now, what is the revelation of Christ today? Of course, on one hand, there is this reappearance in the etheric, but in that lecture he says, the revelation of Christ everywhere in the world is threefoldness. So he spoke there about the threefoldness of the social organism, but when you broaden that, you see everywhere where we discover that sort of threefoldness. And it is quite striking here because really these three particles are the only stable particles on that level. And so everywhere where we find this threefoldness, it can looked at, so to speak, a trace of this being of Christ, or a trace of the one who was connected with this. In the beginning was the Word. That this Word of the beginning reveals itself today as threefoldness. And it is striking that even in the standard model of modern physics, one can find that. And one can see that this strange enigmatic electron has its place there as this mediating quality. thank you for your patience and being with me for this lecture. Maybe we have time for a sort of discussion, questions, and so on. I see in the chat there are already 3.
Dear friends, we are moving question and answer section. And for sake of order, could you please use your chat window? And you don't have to type all your question, but just type a little Q and dot. So, and we will see the order. Who will be first? Who will be second? So, okay.
Barry Leah already asked, is the neutron stable? And the neutron, when it's alone, not in the nucleus, has a half-lifetime of about 15 minutes. It's not. Andrew is.
I posted an excerpt from Esoteric Christianity. You mentioned the Rosicrucians, and you can see it there, but they were looking at the boundary between the physical and etheric. And through moral work, they were able to discover what this was, that all, he says something about all physical substances are built up from this, and I put quotes around the word substance. That's what the translator used. I'm wondering, is this, in a sense, what the quantum particles that have such a short life maybe are what they're finding? Is this what the Rosicrucians, but they can't quite grasp what they're seeing or experiencing because the moral fortitude is not there yet?
Interesting question. Maybe one should look at the quarks again with this in mind, because they are, in a way, hidden particles. It's impossible to discover them in one of these accelerators and so on. But of course, when one thinks of this moral evolution and the clairvoyance of these people, I would assume that it is more something like an image in so to speak, in a level under the physical world, which is projected there from this substance they experienced. But it's just my speculation. Then there is a question on the discussion board about my point of view of the pair creation of electron and positron from photons. So I left that out, that according to Einstein, there is a relationship between mass and energy, as most people know today, with this famous equation: energy equals point m times velocity of light squared. And this famous equation is difficult to verify experimentally, and the most, or the easiest, or the most often experiment which is named there is that if one has strong X-ray or gamma radiation, then this can disappear and an electron and a positron is formed. Or the other way around, if an electron and a positron, so positron is what we call in physics an antiparticle of the electron. If they meet, they can disappear, and gamma burst is coming about with a well-defined energy of 511 kilo EVs. And I think what is interesting to me is that this effect is, as far as I know until today, only known for electron and positrons. It's not known that with, so to speak, real matter, one can show that effect. So of course, sometimes people say when we have radioactive decay and fission and something like that, that changes the mass as well, but it is not in the same way like this electron-positron annihilation effect. So maybe it shows a little bit that the electron is in between, so to speak, between becoming matter and becoming radiation. That would be in conform with my approach.
Thank you, Johannes. Dave Butler, do you still have your question? Dave? Dave, can you hear us? Okay. And next question from Barilia. Am I right by pronouncing Barilia?
Oh, yes, but I think it's already answered.
Okay, excellent.
Ah, Barry, yes.
Oh,
Barry,
Barry,
yeah.
is it you? Okay.
Yeah, it's right. Oh,
Hi, Barry. Okay, Lou Kaufman. Lou, please unmute yourself. We cannot hear you.
Yes, Johannes already answered my question. I was asking about the meaning of the pair creation.
Okay, Waldemar
Yes.
is next. Thank you, Lou. Waldemar?
Yes, thank you. I'm trying to correct the video. Unfortunately, I missed a big part of the lecture. I went up to the Pauli model, the wave model, and then I had to switch computers because there was a mixture of sessions with a family call, with my
Yes.
in Germany.
Whatever.
But what I wanted to comment is the following. The expression wave, light as a wave, for instance, is wrong because wave is a mechanical concept, right? From classical mechanics. And when you are speaking about particles or light and so on, you are not anymore in the realm of classical mechanics. My idea is that the wave is formed when light or particles and so on, for instance, in the double slit experiment with particles or molecules as well, when these particles or light interact with matter, some wave appears, right? But not before, right? So what I wanted to say is that all those particles, I have the impression they don't exist in matter. They appear when you interact, you make in the accelerators, right? Particle accelerators. You interact them with matter or other particles and so on and so forth. And then some effects appear. But I don't think one should extrapolate and say that they exist in matter itself.
Yes, I totally agree. I totally agree. I can even expand that approach. For example, we used to think of water as H2O and think there is hydrogen in the water. And I think from an phenomenological approach, it is not in the water, but it is a transformation of the combination of hydrogen and oxygen into something new, which is water. So I totally agree that the particles are, so to speak, produced out of matter, or yes, let's leave it like that. And
Yes.
my approach here was just more, so to speak, thinking about ordinary theory and what they explain with these particles.
Yes. I don't know of any explanation, maybe I'm wrong, that from the atoms, hydrogen and oxygen, you cannot deduce the properties of water. Is that
Yes,
correct?
that's true. Yes, of course. There are always, even today, but it is especially difficult with water. And there are, every now and then I get an article about the attempt to explain a new a strange property of water by the bonding of these two. But even in a Goetheanistic way, it's difficult when you see the properties of oxygen and hydrogen, how they transform into something like water. But I think there are some possibilities to do that in chemistry. Now there is a question, which from these three stable particles brings death and which life in relation to a living being, organic matter it consists of? I think there is not a simple answer to that, because let me just go back to the picture. Light, of course, is extremely life-bringing to the organisms and especially the plants, but we need it as well. But if the energy is wrong, we have gamma radiation and it's dangerous. Electron is in the theory of modern science present everywhere, mediating in this way. But if it is a strong radiation, it's beta radiation and dangerous. And the same here. It is necessary to form heaviness and matter that we can incarnate. But if it's a strong radiation, it's alpha radiation and it's dangerous. So I think this question, one can't answer this question in the way that one said, this is life and this is death. They all can be both. Then there's a question, when we use electricity as our earth is being pulverized, Steiner says, what is the mechanism of this process and what about the magnetism? Could you comment on these? It's difficult. Maybe I can't, because I need to find the quote of Steiner and look what he could have meant there, because I think we use electricity now for around 170 years. And when we look, not the Earth in the ordinary sense is pulverized, but there are processes connected with the use of electricity, and one has to think about that. So I think I can't answer that question.
Yeah, Johannes, it's a question from Jenny Efland. For some reason, she sent it privately to me. Jenny, can you please unmute yourself and speak?
Thank you.
Yeah, sure.
Recently, the Fermi Lab split the muon. And when they did, the scientists there said that that gives rise to multiple new sub-electronic particles. Sir James Jeans said when the benzene atom was found that he wondered if we were creating these particles as they showed up when we got deeper and deeper into subnature. And I wondered what your opinion was. Are we really creating them? Is Ahriman creating them? Thank you.
So what I can say, I can't answer that question totally in the way that we say we or Ahriman or whoever is creating them. But what one can say is, according to this, or in accordance to this Einstein equation, when we have, when we use in the accelerators like the one in the Fermi Lab, very high energies, out of that energy, in a similar way like the positron and electron pair production, in a similar way we create particles. They are not there, and by the use of this energy they appear, or they appear in detectors, and then they disappear. And normally today, this very high energy physics, in this high energy physics, they would not appear like these traces in the cloud chamber, but there would be some changes in the mass of the other observable particles, and out of that, the mass or the charge or whatever, out of that, people calculate there must have been a particle with that and this property, but maybe only for a few milli or microseconds. So in a way, we create them, and one could say with the help of Ahriman, with these machines, and normally they disappear. And sometimes people have a problem and thinking maybe they might have macroscopic consequences. For example, there were experiments in Genf at the LHC that they might create something like a black hole, and that would gobble up the Earth. And they made huge calculations to be sure that it would not happen, and it did not. But it is a way of creativity by machines.
Barry, there is a statement from you. Would you like to speak? Barry, Leah.
Okay, I'll come back. So related to that creation, I've run across articles by a fellow named Morhoff, Ulrich Morhoff, and just wondered if anybody had explored his work. He's a physicist from England. He's down, if he's still alive, he was down in the Pondicherry ashram in India. That's why it's called the Pondicherry Interpretation of Quantum Mechanics. I put a link in there. And but to my reading of it, simple as I am, as ignorant as I am, one thing he appears to be saying is the quantum world obeys the macro world. And that's derived a little bit from these notions of we create these particles in the machines, through the machines. The machines are part of the macro world, revealing or creating these particles. The particles are obeying the experiment.
I don't know it. And it is, in a way, I think today we have libraries on interpretations of quantum physics and so on. I think, I don't know whether it's still possible for one person to have an overview. Probably not.
Okay, Andrew is next. Andrew Linnell. Andrew?
Thank you so much, Johannes. I think you know this passage about Steiner talking about coagulated electricity. And in the model that you presented, it makes sense in a new way, I believe. I don't know if you wish to comment on what Steiner meant by coagulated electricity in the atom.
No, my only comment is that of course, we realize that there is a certain connections to these theories and pictures of the last 100 years. And on the other hand, I am always a little bit careful because as far as I know, it's a very early lecture where Steiner said that. And then I'm always not that sure whether it has the same meaning we put to his words.
Right.
So like, yes, therefore I'm careful, yes.
Simone is next. Simone.
Is that me?
Johannes, yeah, yes, go ahead.
Okay.
Yeah, thank you.
Thank you. No, I just wanted to ask a question about the first comments, Johannes, and thank you for the lecture about this spiritual imprisonment in the description of science and how we describe the electrons, the protons, etc. And I just put in the chat something that Aristotle had said way back that, and I'll just read it, that he described matter as composed of a combination of earth, air, fire, and water, and that these elements were continuous in movement, and that there was no such thing as the smallest particle. And I just got really curious about that because when we look at the electron, that's non-observable. It's kind of this mysterious place that can't really be seen without a spiritual insight, I think. I'm just really curious. And science is not my major. Eurythmy, but science is not.
I think the interesting thing here is what Waldemar already pointed out. We like to think, and maybe that is part of this prison, we like to think matter consists of atoms. But if you take a crystal and make it smaller and smaller and smaller and smaller, you won't find them. You get dust in the end, and very fine dust, and very, very fine dust. But it is more the way how Waldemar described it, that we can produce these particles out of matter. And then we go back and think the matter is made from them. but I think it is a question of perspective, whether one can try to think of metamorphosis and modification like oxygen and hydrogen coming together change, and then we have water and no oxygen and no hydrogen anymore. And then out of water, we can produce hydrogen and oxygen again. And maybe it is a similar thing with these particles, that it is a little bit strange to say my watch is made from atoms. And when we go in a more phenomenological way, we are probably closer to Aristotle.
Thank you.
Thank you.
Ivan Diaz. Ivan,
Hey, how are you?
hello.
Hello.
A good pleasure from Mexico. Please tell me if this out of theme or not able connected, but lately I've been reading some documents over microbiology on this particle that is found in mostly, in all living being, but it hasn't been studied by science in general, no? or more in the academic science. This particle is called microzeum by Bechamp, was named by Bechamp like that. They also call them symbiont or symbiont, I don't know how to spell it correctly. And speaking of this mediation, what we were talking about, the electron, I don't know if this in a way, it's a mirror or a mediator in way of the creation of matter in the electron value, but in the microsome also in some mediator between the etheric and the life force. So I don't know if you see an association or imaginative connection with this.
Unfortunately, I am not familiar with this microzyme. And okay. I just copied your comment on another document so I can look that up, but I can't relate to that in a proper way. But I can ask my colleagues who are biologists how they look at that, whether they know it. I will see. If you want to stay in contact, then you can just send an email to science section at science@goetheanum.com, and then you'll find that on our website, and refer to my lecture, and then I will know
where it comes from.
Thank you.
Thank you.
Thank you. Sergey Kazachkov is next. Sergey, could you please unmute yourself?
Ich habe eine Bemerkung geschrieben für Johannes.
Okay, Johannes, could you please check
yes, I know it.
Sergey's message?
He asked, there is a tale or a report by Ernst Leers that Steiner said that if we look at current, there is not a movement of elementary particles in the conductor, but a certain process in the environment of the conductor. That is a very interesting thing that Steiner said that, because today we know, and even in that time one should have known that when we think about energy transport, and look at the Maxwell equations for something like energy transport through a wire or a conductor, the energy is not transported inside the wire, but around it. It's according to the Maxwell equation and the Poynting vector. And it is interesting, some people take it serious concerning education, and they say, normally we tell our students, the younger students, that there is a current inside the wire, and this current transfers the energy like water in a pipe. And from a more serious point of view, even in ordinary physics, this is wrong, because the energy is not transported inside the wire. So let's say Steiner was right there, even in an ordinary physical sense. And if someone is more familiar with physics, he can just, or she or he can just look up the Poynting vector, which is the energy vector from the Maxwell equations. Thank you, Sergey, and warm greetings to your wife.
Danke, yeah.
Yeah, Gerald Herman is next. Gerald, could you please unmute yourself? Probably I didn't pronounce well, so Gerard from Netherlands.
Gerald.
Gerald. I'm sorry, Gerald. Okay, Johannes, could you please just read his question from
yes,
from chat? Herman.
Good evening to everybody from Netherlands. A question. Historically, we have the picture proposed by Niels Bohr to view an atom as kind of a copy of the Copernican solar system. The theories of modern physics still combine subatomic viewpoints and galactical viewpoints. Any ideas perhaps whether or how this relates to the Rosicrucian method? Steiner mentions meditating about the Copernican system by the Rosicrucians. Yes, that is in the same lecture where he mentioned that. And in a way, yes, it is a sort of imagination from the Copernican system, solar system. The interesting thing is that in these lectures, this Copernican system is a sign or a symbol of the, let me try to translate. In German, it would be der unrechtmäßige Herrscher dieser Welt. So the unrightful ruler of the world. And that is related in these lectures to the earth as the center with regard to the human being and to the appearance of Christ, and that by the evolution or development of science and the materialistic view, the sun became the unrightful ruler. And in that regard, the Rosicrucians are meditating to transform this image into a right one. And the question is, nevertheless, that in atomic physics, again and again, this relation to the planetary system comes up. And whether that relates to the Rosicrucian method, I am not sure. I know that Georg Unger, who was an anthroposophical physicist and mathematician, and leader of the mathematical and astronomical section, he described once Bohr's system as a sort of imagination in Steiner's use of words. So it is a true imagination of the Bohr system, but I remember quite well that I objected. So I'm not sure, can't answer that question in an enlightening way.
Yeah, thank you. Anne Edison. Anne, are you here? Anne, are you still present?
He's muted.
Oh, Anne, please unmute yourself. We cannot see you. Just click on symbol of a little microphone and unmute yourself.
I think the microphone's not working.
Oh, okay.
It's a man there. He's been trying to speak. Ann Addison is
So,
the name.
and if it's not working, please type your question. So, and we will ask Johannes. Okay, Lou Kaufman again. Lou?
All right, my question is, how do you think about the self-interference of the electron in the double slit experiment? Or more generally, how do you think about the principle that paths are indistinguishable can exhibit interference? Or that interference occurs at the point where the observer can no longer make certain discriminations?
Yes, this question is quite specific and maybe a little technical, and I try to answer that in a short way. When you look, and in the way I can answer, of course, when you look at the at where are phenomena where we are challenged to speak about particles. And then I think it's in a way symbolic that the first, concerning light, the first was Max Planck thinking about emission of light, and the second was Einstein thinking about absorption of light with the photoelectric effect. And even today, when we look at these experiments, the particle suggestion comes out of these single dots which appear on the screen. Tuck, 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 or in the Geiger counter, or in whatever. And so in a way, it seems that, and that is according to the physical approach in physics, it seems that the particle aspect is only useful in emission and absorption, whereas the wave aspect doesn't mean it is a wave, but the wave is, so to speak, ruling the in-between, the emitter and the absorber. And so it makes, in a way, no sense to speak of self-interference, because then we picture the electron as a moving particle, and that seems, or the photon, and that seems to be not sufficient. So we think of ourselves at the unattached or detached observer, and there are moving particles like the water out of the garden hose. And that is obviously not appropriate to this sort of phenomenon. So I would say that the wave function is describing this in between, and I'm not sure about that, but I would assume that when we change the experiment so that we can determine which path, then we change the consistence so that interference can't appear. But I'm not sure about this last word.
But of course, the amazing thing is that if we consider all possible paths, weighting them appropriately and add them up, then we get the right answer, as long as we don't know about any of them particularly.
Yes, that's true. It is amazing, yes. Even for much simpler problems, this is true. Reflection and things like that.
Yeah, thank you. Dr. Yuri Yurchenko, Valdemar is next.
Hello, Johannes. Again, thank you very much for your wonderful presentation.
Thank you.
Could you comment on this question? I learned, I think more than 2 decades ago from the physics, they claimed that the smallest particle consists of light. They didn't mention that proton relates to matter. And also when physics observe the electric current, they say that the cathode is getting smaller, sort of diminishes in matter. Showing us as a proof that the particles are departed from the cathode side.
Yes, that depends. So the word cathode is used for different things. And if you have this tube I showed you, or similar tube like Thomson used with the vacuum and this radiation, there is no change in the cathode, no change which is observable. But when you do, for example, electrolysis in water, then it depends on the material of the cathode, whether it changes or not. And then, so for example, platinum would not change and copper would change. So there is, but that is always related to matter, not to electrons, because the change in the electrons is not observable as far as I know.
Yes, and could you show again that picture which you showed us, where you put the light and matter, this threefoldness? Could you show this again, please, for a moment?
This? Or the next one?
Maybe
The
this
next
one.
is just with these words from the lecture by Steiner. Here's the...
No, I think the previous one. The previous one. Yeah, yes. So at the bottom, you put matter where the proton is.
Yes.
But the physics, they claim that the smallest particle of any matter is light. So do they discard the proton properties then?
No, I think that depends on what one means with the smallest particle, because it is possible, or people think it is possible, with enough energy of radiation to produce a mass like a proton. As far as I know, it's only done with electrons. And the mass of the proton is about 2,000 times the mass of an electron. So the energy needs to be quite high to produce a proton. But I think that is what lies behind that statement, that energy can transform into mass, and therefore energy or radiation or light is the background of that. At least from the ordinary physics point, I think that would be the approach or the reason for that comment.
Mhm. Right, thank you. Thank you very
welcome.
much.
Thank you. It looks like Ann Edison is back. Ann, are you able to speak? No, she's not able to speak. Okay, Waldemar.
Yes, thank you again. Concerning the question of wire transmitting energy, the idea, it is known that the electrons flow in the surface of the wire and not in inside. And it's very easy to understand that, because if we figure out electrons as particles having negative energy, which is, something symbolic. It's not that they have something negative in them. But if they are negative, have a negative charge, then everyone repels the other, so they go to the surface of the wire. So it's not the environment of the wire that carries the energy or the electrons in electric flow, electric current, but the surface of the wire.
Sorry, Waldemar,
yes?
I think that's wrong.
Oh.
When you look at the pointing vector, it's around the wire. And the pointing vector is carrying the energy. I can send an article about that, or many.
Okay. Okay. Well, what I wanted to ask you is about the quantum mechanics equations. Couldn't we use the fact that they are not understandable, right? Some of the elements have no classical limit, so we cannot understand those equations, right? Could we say that then when one look at the particles, we have to use another kind of thinking, and not the classical thinking, the thinking based on our physical senses. So that's what I wanted to say to people that are not anthroposophists, that if we look at those equations, they show us that we cannot understand those particles, right? So we have to use another kind of thinking.
I would agree to that. I'm only always a little bit hesitant when people say it is impossible to understand, because my trust in thinking is that it should be possible, but that we should change or enlarge the way of thinking, because as long as we think in building blocks and more or less unchangeable flying particles, we are not able to understand that. And some of these founders of quantum physics realized that. For example, Bohr once said, the person who gets to know quantum physics and is not shocked has definitely not understood it. That shows that something should be changed there. So there are lots of quotes like that, quotations like that of people, how they realized we are entering into a world where our ordinary thinking is not appropriate.
Yes, Richard Feynman said that if someone says that he has understood quantum mechanics, he has not understood it.
Yes, I know. By Feynman, we have. He was a very rhetoric person. He had wonderful things. Very careful not to start with that. No.
Yeah, thank you. There is one question more from Sergey, but it's all done in German. If you can read it,
I have to find it.
It's from very bottom. I think it's second from bottom.
Ah.
Kann man also und so weiter.
Ah. He said, is it possible to compare most of, now I don't know, he wrote Russian. Most particles. What is this?
I can help with Russian. But,
Teilchen.
Yes. Is it possible to compare most particles with sparks or some glimmering?
Da.
Yes, and
Yes.
I think it is a possibility that something comes up. I know that some physicists describe it like that something comes up and disappears again and comes up and disappears again. So I think as long as it stays a comparison, I agree. Now a long comment by Russell.
Это Kühl. Лекцию читает. Да.
He would like to raise awareness to yet another building interpretation, or perhaps revamping of the boy, because it is particularly appealing in connection with the double slit experiment. It is called the bouncing droplet the bouncing droplet interpretation on or quantum hydrodynamic analogs. I think it could be particularly fruitful to be considered from the anthroposophical standpoint, as it could make connection with a fourth dimension. Here is a obviously materialistically minded video on it. I would also be interested in further discussion this, if it is a direction you want to pursue. I will copy the link.
Or perhaps already have pursued, if you've heard of this.
I have heard of that, but I remember, we get lots of emails with suggestions, and I remember I looked at it, and then I found an article, I looked that up on the internet, where there are some contradictions, and it is not appropriate for the whole thing, and then I stopped to look at it. Maybe it was too early. So I will copy the link and look at it again.
I mean, it's certainly an active area of research now. In fact, part of how I became interested in it is because I'm working in a lab with people who are working on it. And in fact, one of my collaborators just had a paper accepted by Nature on the topic. So it's far from dead. I mean, they're adding various things to it to further understand it, like changing the topography of the bottom of the tub to simulate things like quantum corrals, and incorporating things like Faraday waves and as possible mechanisms, interacting with these bouncing droplets in order to further explain things that are inexplicable. So yeah, I mean, it's very.
Can you write down the name of your colleague or the title of the article? Then I will find it in Nature.
Yes, it just got accepted, so it's not been published yet. But
or just send me the paper.
Yeah, once I get it up. Yeah.
It's just I will not publish it elsewhere, so no problem.
Okay.
So far, I like to say below $1 million, I am honest.
Yeah.
Yes, thank you.
Thank you.
Oh, yeah. Johannes, thank you so much. Dear friends, it's
Oh, past 10 o'clock.
3:04 in Chicago, and this is 10:04 in Dornach, as I understand. So it's a
No, it
evening.
is.
Yeah, exactly. Johannes, thank you so much for your presentation again and again. And we're looking forward in the future to have you with your presentations for Chicago branch and for all worldwide community. So dear friends, please feel free, unmute yourself and greet each other and thank Johannes. And please, if you would like to connect to us, just send emails, send your email address, type it, and I will include you in the list. So, and join us next weekend for 2 presentations. Thank you so
Join
much.
the natural science section in September to hear Johannes again.
Right.
September.
Oh.
Or is it October? Yeah, October for the colloquium.
Ah, yes, climate change, yes.
Okay.
Climate colloquium. And then in August for the MISTEC conference.
Yes, I know. That I have in mind. Thank you. Thank you all for
Yes,
taking
please
part in
unmute yourself, friends,
Lo-
and
Laura, I'll
greet
see-
Johannes.
and some special greetings to Sergey, to Moscow.
Yeah,
We
Vielen
didn't
Dank.
see each other for, I think, 10 years, but
yeah.
before that, we saw each other quite often.
Vielen Dank.
Oh,
Ich bin Deutsche.
ja, hallo, danke.
Hallo.
Thank you,
Thank-
Johannes.
Thank you.
Thank you so much.
Thank you very much.
Thank you, Johannes. Thank you very much.
You're welcome. Thank you.
Goodbye, Johannes.
Goodbye. Hi.
Hi.
Didn't
Yeah.
see you before.
Yeah.
Early.
Okay. Always good to hear your interesting talks.
Thank you. Okay. Eric is there as well.
Thank you.
So long for now.
Okay, then I will leave you. Thank you, Andre, for organizing this meeting, the earlier meeting, and all these meetings, forming a sort of anthroposophical community around the world, actually. The only restriction is the difference of the time zones, I think.
Yeah, it's too bad that Australians, unfortunately, and Koreans cannot join us because it's late night.
Yes.
Yeah.
So
thank you so much, Johannes. Again.
thank you and goodbye to all of you, someone specially.
Good night.